This is section 4.3, and we're going to work with dividing polynomials. And there's really two different things. So if we're dividing by one term, a monomial, there's one technique. So example, if we had 6x cubed minus 3x squared plus 2 divided by 2x squared, that's just one x term. So that's a monomial. So the easiest way is to write it as separate parts. Take each of these and divide by the 2x squared. So we write it out, 6x cubed minus 3x squared plus 2. And on the bottom, the denominator of each, we put 2x squared. Then you begin to cancel out. 2 goes into 6, leaves 3. X squared goes into x cubed, leaves 1x. So we got that there. Here the x squareds cancel out. Here, just the 2's cancel out. Remember that it leaves a 1. So what you're left with is 3x minus 3 over 2 plus 1 over x squared, and that would be your answer. So just remember, if you're dividing by a monomial, write it as separate pieces and then simplify each piece. If we're going to divide by a polynomial, we'll use long division like we used to do before we had calculators. We would do that by hand. So just as a reminder, not anything you have to write down, but as a reminder, if we were doing 25 divided into 638, you don't do it all at once. You think about just this 63 to start with, and 25 goes into 63 2 times. We don't put that 2 here. We move over, and we put it here in the tens place. Then we multiply. 2 times 25 is 50. And we subtract that term. So I drew a line and I get 13. I bring down the 8 and I repeat the process. 25 into 138 goes 5 times, 5 here. 5 times 25 is 125. I subtract, I get 13. 13 is my remainder. This is my quotient. So in some of the questions it will ask you to put the quotient in a box and the remainder in another box. So now let's do that with polynomial. So here's how the problem might be given to you. You want to write it as an old-time division problem with your bar here, your divisor is here, this is your dividend, and you're going to divide this into this. Well, we only want to really focus on this 2x, the start of it, and think about that going into 6x squared. So if that's not intuitive to you to think about, you can write it as 6x squared over 2x, and you could think about that. But as we do it, 2 goes into 6 3 times. The x goes into x squared and leaves 1x. So we've got 3x. We move over and put it over the x term. Now we're going to multiply 3x by both of these terms. So 3x times 2x gives us 6x squared. 3x times 3 gives us 9x. We want to put a subtraction sign out here. I like to put it in a circle. It just reminds me that I'm subtracting even when I have a negative. So here this goes to 0. 5 minus 9 is negative 4x. I bring down the minus 10. Now 2x into a negative 4x just goes negative 2. Multiply negative 2 by this. I get negative 4x, and then negative 2 times 3 is negative 6. I'm subtracting all of this, so I've got two negatives here. So when you do that, it's negative 10 minus a negative. That becomes a plus. So negative 10 plus 6 is a minus 4. Minus 4 is the remainder. So if it's two separate boxes, here's your quotient, here's your remainder. Or if you have to write it in one long thing, you've got 3x minus 2 minus whatever your remainder is over the divisor, over 2x plus 3. All right, let's look at the remainder theorem. If f of x is divided by parentheses x minus k, where k is this number inside, the remainder is f of k, meaning you don't really have to do the division. You can just take k and plug it in. So if this is the problem, x squared plus 8x minus 17 divided by x plus 3, Well, it's x minus k. So k, in this case, would be a negative 3, because x minus a negative would give you this x plus 3. So if we do f of negative 3, that means plug that into the equation. Negative 3 squared plus 8 times negative 3 minus 17 equals negative 32. And that would be the remainder. That doesn't tell you the answer if you divided it. It just says that's what the remainder is going to be. The factor theorem talks about f of x has a factor x minus k if and only if f of k is 0. So that means if you did f of something here and you got 0, then you don't have a remainder, and that means it went in evenly. So if your f of k is a 0, that means that thing you're dividing is a factor. So we're going to do some with that. Now let's look at synthetic division. Many of you may have already learned that. If you haven't, it is just a shortcut to use in dividing, but your divisor must be a plain x, not x squared, 3x, anything like that. Plain x. So here, if we had this as our dividend divided by x minus 2, we can use synthetic division because this x is a plain x. The strategy is take only the numbers and make sure you account if one of the terms is missing, you put a 0 there. So we don't have an x squared, so we'll put a 0. So we have 3 minus 7, 0, minus 4, and 5. We write those down. Draw a backwards L, and inside here we're going to put K. If it's inside parentheses, when we pull it out, it changes sign. So that's a positive 2. First step, bring down this number. That's 3. That's all you do. Bring it down, whatever it is. From then on, it is multiplying here. So 3 times 2 is 6. Write it here. Now add. Negative 7 plus 6 is a minus 1. Again, minus 1 times 2 is a minus 2. Add, we get negative 2. Negative 2 times 2 is negative 4. Add, we get negative 8. Negative 8 times 2, negative 16. We add, we get negative 11. And we are through as far as the numbers go. Now, we've divided in an x term, so this degree always drops down 1. So you put back your x's. You've got an x cubed, an x squared, an x, a constant, and the last number is your remainder. So we'll go through that in some of our problems, but those are the notes that are going to get us ready for our problem set. Now let's go look at those. All right, for number 1, this is like the first thing in our notes. Perform the indicated division, and we're dividing by a monomial, one term. So separate it into pieces and then simplify. So the x cubes cancel out, you're left with 5. The x squared goes into the x cubed down here, leaves a 1 on top and an x down here, plus 2 over x cubed. So your final answer looks like that. Divide the first polynomial by the second. And so we do that. We'll write it as an old-time division problem, divided by x minus 6. X goes into x cubed, x squared times. And what that means is that you've got x cubed divided by x, and you cancel out, and you're left with an x squared on top. Let me show you one thing on that. So if we have x cubed divided by x, remember that's the same as x times x times x over x. And so those two are gone, and you're left with x squared on top. If you have to think of it that way, rather than just it being intuitive, that's fine. And so that, I wanted you to see that that is what's happening there. Then we'll multiply. X squared times x is x cubed. X squared times minus 6 is minus 6x squared. Put your minus in a circle, just to remind you. Minus 4x squared minus a minus, so that's a plus. So now that's 6x squared minus 4x squared. We get 2x squared. bring down your next term, repeat the process. You go through it like that the whole way, and you have x squared plus 2x minus 4. There was a 0 here, so the remainder is 0, and the quotient goes here. So this part goes in that box. You do the same thing with number 3, and you've got x plus 1 dividing into this. X into 2x to the 4th goes 2x cubed. Put it over the x cubed term. Then do your multiplying by both terms. Do a subtraction. And you just do that all the way down till you get to here. We're left with 32. So the quotient is this part in a box. 32 is your remainder. This one, same idea. Now it's W's. So doesn't matter, that's the same. So we'll be w minus 3 into this one. Now we have to take note that there is not a w term. We went from w squared to the constant. So we had to put 0w in to do the problem. Then we do it the same way. W into negative 4w cubed is negative 4w squared. And then we go through the whole thing. Remember here, you're pulling down 0w. That's fine. You're still going to do the problem the same way, and you get negative 71 for your remainder. So quotient goes here, and remainder goes here. Number 5. 4x plus 2 divided into this. We weren't missing any pieces, so we didn't have any zeros. 4x into 8x cubed goes 2x squared. Multiply that by both, and you come down here. Repeat that process, you get a remainder of 0. So there's not even a box for the remainder, so that works fine. Number 6, we're going to do it with synthetic division. And we're dividing by x plus 2 here. And so we're going to use k as a negative 2 because you're dividing by, get this, you're dividing by x plus 2. So when you pull that out, when you pull out the number that comes out, your k is going to be a negative 2. So we want to remember that as we do these. So we'll take the numbers here, 1, 4, 6, 4. Put that in a line. We're doing a backwards L, and we're putting negative 2 there. First number, just draw an arrow and put it down here. The rest of the time, you are multiplying and then adding. So 1 times negative 2, put it here. 4 minus 2 is 2. 2 times negative 2 is negative 4. Add, you get 2. 2 times negative 2 is negative 4. Add, you get 0. You drop down one level because you're doing x cubed, and your answer will be an x squared. So this is x squared plus 2x plus 2. Remainder is 0. Number 7, same idea. If the divisor is written as x minus k, if the value of k is, so it's just reminding you that if you're dividing by x minus 4, your k is going to be 4. So 4 goes in your backwards L. We have 6 minus 27, 7, and 22. Bring down your 6, then it's multiply and add, multiply and add. So this is your quotient, so that's 6x squared minus 3x minus 5, and it wants the remainder over the divisor. So the remainder is 2 over x minus 4. And that all of this goes in the box for number 7. Number 8, we're dividing by this. We're dividing this by x minus 3, so our k value is 3. We do our synthetic division. That means our remainder is 2. So you have 6x squared minus 3x minus 1 plus, and they want you to put the remainder over the x minus 3 here. Number 9, same idea. We're still just doing synthetic division. It said divide by x minus 4, so your k value is 4. You have a remainder of 0. Number 10, This one just wants the remainder, and it says use the remainder theorem. Remember, that says we're going to do f of k. Well, here our k would be 3. So f of 3, we plug that into our equation that's given, and we get the value of 21. So when you divide x minus 3 into this, this just tells you your remainder is 21. Number 11, same idea, remainder theorem. If you're dividing by x plus 4, you do f of negative 4. You plug that in here, do your math, you get negative 4. Number 12, a little bit of an application problem. The area of this rectangle is 35x squared minus 53x minus 18, and its length is 7x plus 2 inches. Find its width. Okay, so we need to do some dividing. Before I actually did the dividing, I wanted to write out here, area is equal to length times width. So area equals length times W. We divide this number, this whole expression over here, that's what width is. This divided by this. So we come over here and do it with long division. 7x goes into that 5x times, multiply, put here, subtract. You get negative 63x here, bring down the negative 18. And when we subtract, we get 0. So this is our width, and that's what goes here. So I think that is dividing polynomials and using the remainder theorem, and we should be good. That'll get you on 4.3.